Okay, 7.221, let's finish up that one. So we have the tent problem, and it's a big size tent. So it's a circus tent. So maybe more like this right here. That works, Natalie? So 51-foot wire is stretched from the top all the way out to here. And we know that for sure. And to the ground makes a, and it also makes a 58-degree angle right over here. Okay, with the ground. If the length of the tent pole is 44 feet, so this guy's coming down like this.
But not necessarily a right angle.
Mm-hmm. So we don't know if this, yeah, not necessarily like that. That's our issue. Is it positioned well? Is it off just a little bit? Is it the leaning tower of Pisa? That's kind of what we're looking at. How far is it from the bottom of the tent pole to the point where the wire is fastened to the ground? So we're trying to figure out that piece right here. That's our X value right there. So the tent pole is not necessarily perpendicular to the ground. So we're going to go like this just to make sure that we understand that's not a right angle.
Use the ratio thing to find all three angles, right? And take that kind of back.
Talk to me.
If you use the ratio thing, you can find the angle the tent pole makes at the ground, like sine.
Yes, So like we did before, let's flip this over. So this is going to go this way just to test, right? We need a test to make sure we have everything we need because the ambiguous case is still here. So 58 degrees goes this way, 44 is here, 51 is here. That's the way we've learned 7.1, right? Test it. So we just need to make sure it hits the ground. Not necessarily that it, yeah, let's see. Test point is what? All yours.
Drop it down.
Yeah, we can drop this down, right? But the H is dropped down.
Yeah.
Boom. So H is equal to?
Sine of 58 equals H over 58.
H, we have an even easier formula for H, don't we? It's just this right here. It's just 51 sine of 58.
Oh, yeah.
It's these two with the sine of 58 degrees here. So anybody with a calculator, go for it, please. 51 sine of 58 degrees, give me that. Recording, yeah, recording, okay.
43.25.
43.25, okay. Do we have enough?
Barely.
Yeah, barely. And it should be that way because it's a tent pole that's fixed. Dylan, we're doing 21. 21 off of 7.2. The formula was B, remember sine of A, right? That was our little formula for H.
Is that in the formula?
No, that is on, as we went through the textbook here.
Oh, yeah.
Yeah, that's the textbook page, page 352 in the textbook. And I'll print this out for you guys for the exam, so you guys have the conditions and cases in front of you. Okay, so real quick here, guys, how many cases?
One. Oh, no, it is on, so it could be two.
Yeah, so we have 44. So this guy's coming down like this right here, right? It's just a little bit more, right? So it can swing this way, or it could swing this way as well, right? So we have ourselves that possibility or that possibility. And this is cool because this is the first time we actually see a real life experience of why this is happening. Huh?
The other one where
Yeah,
it's
he said all we have to do
the
is draw
inside,
it.
Uh-huh.
We did those in class.
does it really work? Does it have holes?
So this is finally a real life example of all the abstract stuff we were doing, right? So the pole is either leaning this way, right? And it's being pulled down by the wire that's there, right? Or they stuck the pole like this and it's kind of leaning off this way and they staked it so that it would have more resistance. So notice this is kind of like a little bit above 90 degrees. And this would be like a little bit below 90 degrees. Does that make sense? So two different possibilities based upon just the numbers we know. Cool. Me staking tent poles usually it's this one right here, right? Usually you have tension on the wire Right, you stake the pole and then you tension the wire so that it's sitting exactly how you want it to sit. But let's go for it here. Everybody clear though? We have two cases on our hands we got to think about. Okay, so a little bit above that, let's jam with the two cases then. So we're gonna, let me do this case first. We're gonna set up both cases. That's the first one we do. So I'm gonna just label this as A, B, C. 58 degrees comes right here, 51 is here, 44 is here. And we're gonna find B first. The other case is going this way now. A prime, we call it B prime, C prime. Remember that whenever you have two cases, you list them. So this is little a prime, little b prime, little b prime, little c prime. Okay. All right, sine of 48 degrees over 44 is sine of b over 51. Anybody help me out with the calculator on this one? And tell me if I put down numbers, if there's a number, you're like, what, Mr. Ng, where did you get that number? Please tell me.
I think about 0.98.
0.98 for this little piece right here, right? 0.98, which should be the case. Now take sine inverse. What mode should we be in on calculators? Degree mode. Make sure you're in degree mode or else it's going to look off. So it's anybody.
79.4.
And anybody check, Isabel. I need a second here. 79.4. Not that we need to check, Isabel, but just in case.
Oh, sorry, what am I checking? I was doing this. Checking the 51 cent here.
Yeah, and making sure that the value
And
is.
then sine inverse of that. I got something.
Got the same thing? Okay. Got a second and maybe a third? Yes. Okay. So before we get going anywhere else, let's just stop here real quick here. We're going to go back over here and we're going to get B prime right away. Anybody tell me how do you get B prime?
180 minus that and then
Absolutely. And what would that angle be? 100?
Yes.
100.6 degrees. Okay. Talk to me. What are we trying to find? Because this is a real life problem. This is not abstract. We're not trying to find all the pieces of a triangle. We're just trying to find one piece. C. Okay. So my slide is running out of room here. So let's go back to this one right here. Let's find C right now for the first one now.
And we need to do 180 minus 79.4 because of. Again?
Yeah, sure, Dylan, absolutely. So this is what we've been talking about. So if you have let me go back to the previous slide here. So this is what's happening here. You have a isosceles triangle on your hands when this little 44 meters, when it swings both ways this way. Notice an isosceles triangle from geometry, because everybody remembers geometry, that this angle here and this angle here are exactly the same.
Right, okay.
Now it makes sense? Yep. So then this guy has to be the supplementary angle to it. Absolutely. Good. Let's jam. So this one, I set this up. You guys give me that setup. Yeah, that setup and this setup. Is that right? Oh, we need to find C now. Look at that. We are finding everything here. Because in order to get little c, we got to find angle C. What's angle C?
Yeah, angle C would be 100 or 180 minus 137.4, so 42.6.
Whoa. It's 79.4, right? Plus 58, and subtract that from 180. Sorry, go ahead. We'll say again. How much is it?
42.6.
42. Come on, pen is not writing.
Sine of 58 over 44 equals sine of 42.6 over C. C equals 44 sine of 42.6 over sine of 58.
Okay, Atali, you asked that question. Is that good now? Makes sense now? Okay. All right, anybody get the answer?
I have 35.38, but I did a different mapping earlier, so I use that.
Yeah, I'll go with 35. Okay, so we're keep on going from the previous slide here.
Oh, yeah, now we have the.
Angle
It's
C
186.
is 21.4.
Cool, okay, let me go back. Some people are still writing here, so let me go. Wait just a bit here.
No, this one. I switched it after.
Hey, Dylan, good there with that? Okay. You asked the questions we need to. Okay, can I go back now to the previous slide? Dunk. So I have 100.6, so that angle C would be, or C prime, 50, 21.4. Okay, and everybody okay with where I got the 21.4? Cool. And then I can finish this one off faster. So C, little c prime, solving for that, it'd be sine.
58 over 44. Also, can you just plug it in back to what we had before, and switch the sine of 43 to sine of 21?
Absolutely, yeah. If you already have it written in your calculator, please do so. Little c prime. So little c prime would be 44 sine of 100.6 degrees over sine of 58 degrees.
160.
Oh, sorry. Thank you. The 21.4. Thank you.
18.9.
So I'm going to go 19 feet.
I got 20.
Okay, let's go back to the tent. Since this is such a cool problem to, so this guy, it's not just a little bit off, it's like way off, right? The tent is either like this, it's either staked. So here's my little tent. Right here, right? So two different possibilities. It could be this stake is kind of like this, right? And it comes out this way. And if that's the case, then it's just 19 feet away. It could be that it's staked.
Oh, that is a big difference.
Yeah.
16 foot.
That's a huge difference.
Oh,
Or if it's like this, then it's 35 feet away. Again, this is such a good problem because it illustrates the fact of the ambiguous case, right? The two cases, right? And so, yeah, I'm not sure why they did it. There's a different
That
pole.
would be actually both triangles.
you had it on either side.
We have one on either side.
You had it.
He's going to say again.
It basically, if you had both, because you'd have one on either side, and in theory, you would also have another line going at the other side
Mhm.
of the tent, so having both lines there can make more sense, honestly, than just one of them.
Okay. I'm going to go with it.
Keeping the tent upright.
Yeah, you're gonna have another pole or something like that. Yeah. And then probably smaller poles, or you're gonna have at least lines this way as well, right? Because you're gonna have other cords. Okay. 21 is good now? Sweet. I want to do that problem because it gives you that sort of like concrete illustration of very abstract two possibilities. Okay, so let's jam. We are going on to area of triangles, guys. 7.4, area of a triangle. Mrs. Rain, if you would be here on Friday, it would be even better because we're going to talk about hero, heroine, formula. We should talk about this guy. This guy's super cool. We're going to talk about it anyways. And then we'll do the proof for it in just a bit here. So let me lead into it. How about that? It'll be kind of fun to lead into it. Then we'll come back to the lesson at hand. So area formula for a triangle, go. Anybody? I got a triangle. Yeah, I've heard that over and over again, huh? So if I have A, B, C, I have area, triangle. Notice we use area for the area of a triangle, and then we use area for a vertice of a triangle, right? So kind of careful there. That could get confused sometimes, but it's 1/2 times base times height. That's cool. Because we've learned trigonometry and because we've taken a lot of time to do work with triangles, we can come up with some awesome stuff. We're good? So we're gonna go like this. How about, let's say you are calculating, oh, this would be great, a river or something, right? You just calculate the distance of a river. And what you do is you can figure out this side here, you can figure the length here, you know this angle, and you know this length too here, right? And you're trying to figure out the area that's here. You're trying to make a park.
Oh, yeah, it's all you need is, you can get the height, right, by just doing like sine of that angle. You already know it.
Okay, cool. Noah's getting in here. I'm trying to figure out the area just straight from that. I want to know two sides and an angle. That's it.
Oh,
I don't
You don't
know.
have to find anything else.
So you're saying we're not trying to get to the formula, we're coming up with the formula?
Uh-huh.
Oh, okay.
So this is so cool. So guys, instead of going over here, right, I would have to go and measure this then, right? Then I'd have to measure, then this is already given, but I would have to measure that, and I can't because I'm going through a river. I'm going through a lake. That's not going to be nice to measure. So now the question is, can I come up with a formula? Now Heron, or Hero, got to introduce him because he's cool. So sometimes he spells his name with an N, sometimes he doesn't. It just depends if it's Friday or Thursday. So he came up with a system like, okay, if I can do this, can I figure out an area for a triangle just based upon sides only? It's like side 1, side 2, side 3. That's it. What do you guys think about that? Think about how that happened and go from there. But just a quick little thing on him. We have him all.
No angles.
No angles, just sides only.
That makes sense,
So.
if you have 3 angles, you don't know how big it is. If you have 3 sides, you do.
Mm-hmm. And let's see, I had him around here somewhere. Where did he go? Oh yeah, he's right over here. Oh, same picture, is that right?
Yes.
Love it. Connection, all right. So just a quick about him. During 10 AD, a mathematician emerged in classical age, transformed the landscape of mathematical science. He is super cool. He was the greatest experimenter of antiquity. He invented several equipments, steam-powered devices, windmills, harnessing agricultural wind. Let's see, what else did he do? He made these just games, puzzles, hundreds of puzzles, just for fun. He is the first one that's credited as developing the rudimentary pieces of a propulsion engine. Guys, this is propulsion engines in 10 AD. And so and he made a gun. Yes, he made a gun.
Super question.
Gotta wait till Friday.
Do you have gunpowder?
No,
No.
without gunpowder, he made a gun. I know, he's just awesome. Okay, so before we get there though, let's go back to here. So lesson for today, we're gonna figure out the area of a triangle based upon 2 sides and the included angles. So we wanna say SAS, that's what we wanna do there. Then we wanna calculate the area given 2 angles and a side. So we wanna be able to do it by angle, and a side. What is that happening? And then we're gonna figure out semi-perimeter, but that's just to lead to Heron's formula. We're good? Let's begin.
What is the side for?
Semi-perimeter, we'll talk about it. It's kind of perimeter of a triangle, but that's where we have the lesson. Let's jam. So here it is, 2 sides and included angle. So if you want to label this lecture part, just do SAS. And of course we derive stuff in this class because we're cool like that. So here's my triangle. We're going to derive the formula based upon 2 angles and a side. Here it is, ABC. Yeah, let me get to this page over here. Like to better do it on the wall. I'm going to drop a height here. I got this right here. Let's see, this is C here. That's A, that's B. Formula for a area of a triangle is 1/2 times the base times the height. Is that right? Okay. Easy stuff. Let's think about it just for a bit. Based upon angle A, can you tell me anything you know about trig functions that include sine?
Sine B equals H over.
Oh, I need sine of A.
Oh, sine of A equals.
Sine of A is equal to H over B. Okay.
Multiply by B and you replace the H with B sine.
Multiply by B. And we just developed, guys, we just developed a whole new, brand new formula for the area of a triangle. Let's go with it here. We just replace H with that H over here. And area of a triangle now is 1/2.
What's B squared sine of A? Because you added a B. Right?
Ooh, yeah, hold on. I guess there's a little problem. One second. Is that B the same thing as this B?
No.
Oh, you're right.
Oh, that's the base, right? One's a base and
I
one's,
know.
what is our base?
C.
C, okay. So careful there, that's C. And then let's bring this over. So this is B sine of A, okay. Make it look nice. In the formula, what we do is with that B and the C, just put them in alphabetical order, that's all. So 1/2 times BC sine of A. C is our,
Formula is actually the base, not actually sine of B,
Okay,
so just swap it out.
okay.
so kind of careful, yeah, and especially in trigonometry and calculus, we will have variables that are multiple use variables here. So kind of be careful what you're talking about when you do that. Okay, we're good there with that formula? So can you guys reiterate the numbers around? So if that's the formula, right? If we used angle B, let's get this one then. So-
B is just A sine, AC sine of B, right?
Yeah, and all these letters are gonna move around, right? So Isabel, what did you say? It's gonna be 1/2
AC sine of B.
AC sine of B. Awesome. Let's put all these formulas down so we have them on one page here. So I have 1/2 BC sine of A. And if we move them around, we can prove it as well, but it'll just be 1/2 AC sine of B.
Now it's C.
C, let's go for it here. Good question. Question is, can we do it with C? So all we do is we do this. Let's prove the other one here real quick here. So if we do sine of B, that's H, is that right? So this would be sine of B is equal to H over A, is that right? So A sine B equals H, and the replacement comes in. Is that all we need right there? Everybody's sure of that now? Okay, let me switch pin colors because it's red. I'm gonna go to black here. Okay, so Isabel, question for you. If I put a hypotenuse this way, is my triangle still the same? Have I changed the triangle any?
No.
No, that's the same triangle. So if I designate this to be H, go ahead.
The base is different.
Yes, the base is different, Okay, so let's go, because that's gonna be a difficult one here, so I'm gonna redraw it. So this is ABC, you guys make sure I don't make a mistake here. I put the H this way now. This is what, little b, little a, and little c, is that right? Okay,
So
you guys talk to me, go for it.
we have BC sine of C.
So I need sine of C though. Sine of C is,
Oh, that
because we're looking from this side down,
H over A.
H over A, So it's gonna be A sine C over H, that's cool.
So it's AC. It's AB sine of C.
How come it's AB sine of C?
The
The
original
base
B
is
is. This is
Yeah.
actually-
Yeah, the B actually is the base, right? The B is the base as well as the base on our formula. Okay, good there. Dylan, does that make sense?
I think that's.
That's
I
cool.
Still don't quite understand why you're having sign there, just yet, where you know side A, and side C, or side B, and side C.
Ah, we have sign because we're trying to
Oh,
wrap
right,
this.
we're trying to find the height.
Uh-huh,
Okay.
that's the height. That's cool. Mrs. Rain, the cool thing is we're gonna say, hey, Dylan, does that make sense? I get like a 2-for-1. It's kind of cool. Okay, so we got ourselves, let's see, AC, is that right? No, AB, right? Sine of C. Okay, let's use this. Let's use this as our problem now. So we have this on our hands here. Find the area of a triangle that, ooh, this is an obtuse triangle. We can still handle it. All yours, guys. Can you draw it out? Once you draw it out, give me the formula. But draw it out first, just so you have a diagram of it.
Using side C area or no?
Say that again, Dylan.
So like we have side B and side A to get the area, but how do you do the side C? Wait, the question is that.
Yeah, uh-huh.
So have we gotten to that yet?
But yeah, that was this one right here.
So it's just A side C. Oh, okay, I understand.
Yeah, and what we do is we just change our hypotenuse, but we don't change our triangle. Our triangle is still the same. Okay, guys, go for it. 30 seconds. Try it yourself. Go. Label the triangle, diagram the triangle, put in all the values there. Make sure you have a angle side angle property, and go for it. And I'm gonna walk around. This is where I get to walk around and make sure you guys work.
Yeah,
It's what?
I already calculated that. So that would be deal.
Ask away if you need my help. Okay, and as I'm walking around here, I know sometimes you guys are trying to draw it to scale as you guys are looking at it. You know, it's 124 degrees, right? You kind of say like,
Does not look like this. Oh, that's the form.
Yeah, it's, wait, no. Oh, wait, then divided by 2. Oh, no, there's a half. You know what? I don't know if that's right. Is this?
go ahead, good.
Is
Sorry.
this like, oh, well.
You did 1/2 times base times height, right?
Yeah.
But we're trying to work with a formula that has sine inside of it as well.
Oh, no, I have signed it. Yeah. Did 1/2 and then B and then C. Right, because the first
That's
one
what
1/2
you're
times, I did 1/2,
Uh-huh.
and then it, where, yeah, 1/2 times B, which is 64.3, and 75. I don't know, 89.
Yeah, that's weird. I don't know why it's not going over.
Well, I'll just run it again, but I did, but I put everything in
Yeah, let me check. Let me just check my answer on my little sheet that I have.
64.3, 75.2, and
Do
then
you switch?
sine of, what's the
Which-
conversion of minutes?
If you're going from minutes to decimal degrees, take 40 and divide it by 60.
Which is just 2/40 divided by 60.
No, 40 divided by 60.
It's 2/3, so just add 2/3.
It is. Yeah, 124 and 2/3.
Really big.
Yeah.
Mr. Hunter,
Yeah.
I'm confused
Let me
because
just check on that.
A is bigger now, so you can't have your hypotenuse in the same place again.
Good, good. So we don't care about the hypotenuse now because we already developed the formula. So I don't
Doesn't
care
matter?
about, yeah, so at this point, I don't care about my the hypotenuse.
We know this is a triangle, right? So now we find the area.
Yeah, as long as I know it's a triangle, I stick in the formula, as long as I know that it's side angle side.
Yeah.
It's the included
Alright.
side
That
there.
works for me.
So what'd you guys get? Anybody's getting, oh, make sure you guys are in what mode?
Degree.
Degree mode, check mode on your calculator.
Yeah, I got 1988.
Okay, I got a 1988, sounds like a year.
75.2.
And Tolly, what'd you guys get? What'd you get?
I got the same thing.
Okay, and Dylan? Sweet, okay, we're getting 1988
Hang
for our
on.
answer.
Sine of
And then,
124 and
so, because we've developed these formulas right here, right? We just want to make sure.
1988.481588.
And so we're just gonna plug into that. And that's it. Okay,
So that would be, it's gonna be a square.
Oh, yeah, that's cool. Yeah, so area
Yes.
has to be a square unit.
Oh,
So centimeters squared. Oh, yeah, I'm gonna love taking off points on the test.
oh,
When
no.
it's just 1988, what, is that a year?
As long as you put centimeters after, we have half credit.
Half a point off, I could do that.
Square,
Okay.
give us a quarter. You know.
Bless you. Okay, so let's jam. I think it looks like this right here, right? This is ABC.
Oh, I did not.
120.
Oh, no.
40?
I did, and I was like, I thought it was so bad.
Dylan, let me punch it into the calculator so you see it as well. So a little, okay, little B, little C, boom, we're good there. And then us tackling this little, you guys now comfortable with pieces of fraction, pieces of degrees now? Okay,
Finally was able to make myself remember that the right way around.
oh, good, good. 1 divided by 2 times, was it 64? I'm gonna do it 64.3 times. You guys make sure I'm not doing anything wrong here. Times and bless you. And this is what's,
Sine of 1
5 pi over 3 radians or something.
that's true, yes.
way easier.
Why does yours go
It
below?
also makes adding degrees to get an angle.
Uh-huh, so, ooh, I almost messed up. I got degrees here. Okay.
Add up to 2 pi.
Okay, are we good there? 40 over 60, is that the way you do minutes, right? Because we divide pieces out of it? Shoot,
I
188.
did, I literally wrote 124 with 2 30s.
Centimeters squared, awesome, okay, sweet. Okay, one job is done. The next one is what happens if we have 2 angles on the side? So if we want to do this one here, this would look like AAS, right? So we're looking at AAS. The next side. Okay. So I got my ABC again. You guys good there? Let's see. And
Angle side or angle side angle, because that's different. It does not matter.
let's see.
I think it was angle science.
Angle side, and then it won't really matter because we'll see something along the way. Okay, so let's jam. Let's see, let's take one formula that we know. We have this triangle. Don't we have this formula already? So BC, right? That's the first formula came out. BC sine of A. That's cool. I know this, I know that. That's awesome. I'm going to pose a question here, and you guys think about it here for me. Law of sines. Law of sines. And I'm going to start the formula for you guys and see if you guys can finish the formula for me.
We had a lot of signs like sine of A over A.
Yeah,
Uh-huh. Yeah, that's all we need. In fact, no, just to make it easier, hold on, because that would, sorry guys, real quick here. Let's change these up just a little bit, just to be easier for us to see it. So, Mrs. Rain, that was my first mistake ever in math class right here. 1/2, let's do 1/2 AB sine of C. Okay, so I'm gonna write it on the board and you guys see what you guys see and tell me what you guys see. That right there. And is there a way to fuse these guys together?
Well, that's sine of C. Does that mean that 1/2 AB equals?
Notice we have a sine C in our formula already, right? But we have these two variables called A and B. And I want to get a second angle into here. Can I substitute? Yeah, actually, Isabel's right. You have to pick one. Which one do you want to substitute, A or the B? Isabel gets to pick it because she said it.
Let's say substitute B.
B, okay,
Well,
sounds good, let's go with it.
I think you have, technically it's still.
Yeah, let's cross multiply these guys. So we have A sine of B is equal to B sine of A, divide by sine of A.
So B equals A sine of B over sine.
So
We have
B,
one house A,
A,
A sine of B over sine of A. Sine of
Okay.
B.
this gets crazy. Okay, let's go for it. Let's plug it in. So I have 1/2. A stays the same, is that right? And then B has now become A sine of B over sine of A times sine C. So let's make this just a little bit more nice looking. So how about 1/2 A squared? And on top, what we have is we have sine of B, sine of C, all over. We have two fractions in there. What should we do?
Can't you just write that as 2 sine of A?
Sounds good. How about this?
Which is what I'm doing this entire time anyway.
Okay, let's get rid of the 1. Let's get rid of all this. And let's just write the bottom as 2 sine A. Are we good there? And then we should make this equal to, again, that capital A is area of a triangle.
An extra big capital.
Huge A capital.
That's what I've been doing since I
Okay.
know.
Next, I'm gonna walk around. You guys give me the other 2 formulas based upon that, because you could use this.
Are you sure?
You don't have to derive it. You have to just write them down based upon you changing the angle measure, angles and sides around.
Oh,
Wait, other 2?
it's actually,
So-
it's not as bad as it
You can get more sine of C in there?
You're not deriving the formula. You're just changing the angle measurements and you're just changing the where the position are of your angles. Okay, so notice on top you have A, which is your sine. You have sine of B, sine of C. But then your angle measurement is sine of A on the bottom. Good. So little a and big A.
is. Like this, are these the remaining?
Yep. So if you had B squared in the formula, what would the
One
angles?
side you have the corresponding angles on the bottom. So you do B squared sine of A sine of C is equal to 2 sine of C. B.
Cool, awesome.
Just
So
moving
it's
them.
super complicated to me.
If this comes up on the test, we'll have to derive this on our own.
No, the formulas are on the formula sheet.
And
We're just deriving them today. So I'm gonna walk around, make sure you guys got it here. Go for it. Derive the next formula. So next formula should be B squared.
I
Right?
don't think I see these on the formula sheet.
Little squared. And then think about the angles that have changed.
We said he'd give
So
us
sine of A.
formulas that are on the relationship.
Well, no, not the specific one that we're doing right now, it's not on the formula sheet, and I don't think it's in the book either.
But this isn't a formula, are we gonna use this, or are we just using all these to find one formula? the Heron?
No, we're gonna use these as different formulas here. So
Yeah, so we're gonna have to derive this in particular on our own, on the test.
no, I'll give it to you. I'll give you the area formula
Yeah.
sheets.
Well, the area formula is on here, the one that we did previously.
It is weird.
Oh, you just wrote it over 2.
Log cos, wait,
Yes, it's better that way.
Yeah, log cosines is on here, log sines is on here.
yeah, but the area is not.
Yeah, first chapter 7, I do have to give you an extra sheet.
Well, Dylan, bottom of the 3rd page, right bottom, it's area triangle 7.4, and has half of
Where?
A, B side of C. 3rd page on it, I think. The one with the unit circle.
It has some stuff. I don't know what the square root thing is. Or
Yeah, but it has one we just did, the S equals,
Yeah, it is square
Yeah, it has
side
the
of
A
B side of
squared.
C over 2 side of A.
and the other 2 you can like get easily from that, you just substitute them.
I will, yeah, I'll give all of them for you, because that's, once we derive it in class, we have it. Okay, well, Jam, are we good there? Let me see if we did it all correct. So here it is. It should be area is, let me go back to this one here. A squared, you guys have to help me out here. A squared, sine of B, right? Sine of C all over
2 sine of
sine of A. That's the first one. Second one, yep.
B squared.
B squared.
Sine of A sine of C over 2 sine of B. 2 sine.
Oh, 2, And last one,
C squared sine of A sine of B over 2 sine of C. Where did all of our numbers go? One left. So sad.
You guys have reached to the point of mathematics that numbers don't matter anymore.
Yeah.
Just letters and symbols, and that's about it.
Just a little-
Okay, yours. Ready? I got 2 people still writing it out. Go for it. Dun, 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 dun. All yours. Go. Find the area given that. I should mention real quick here. Let's go back over here. How many angles do you guys see in each of those formulas?
Oh.
3. Okay, so this formula is not, even though it says angle, angle, side.
You have to find, well, if you have 2 angles, you have to find them.
Yes, with this 2 angles, you do have to find the third one in order to use the formula itself. So it's,
No, it's not that bad.
yes,
It's the
correct.
easiest thing you can do.
From here forward, are we gonna using minutes more? Because I feel like they've been adding minutes back in after a while. to a lot of times.
Yeah, in a lot of application sections, when you're dealing with physical stuff, decimal degrees come in and minutes come in as well.
They're
That's
really
not the
annoying.
reason I find the minutes are not because you have to come with it.
89, well, that's just 90. Boy, that's actually. Is it- hey, this is 90.
It's all yours. Go for it. I'll walk around, make sure you guys are jamming with it here. I guess we are going to get to here's formula. Because last year, for some reason, I did it in 2 days. This one, but maybe because we did, maybe there was homework questions that took up half the class. Okay, so go for it. I walk around, you guys do the work.
Wait, which one's the loop again? Oh, yes, which one's the loop one? Okay. All divided by. Yeah, that sounds right.
All right, and then again, check with the person next to you, sir. See if they get the same thing. Hey, what'd you get?
I got 28.96.
28.96, okay.
I'm a very long calculator.
Oh my god. What is it? Okay.
It's been an angle, sorry. Okay.
So.
Oh.
75 and 2.
There's like another way to do this one because you already have the height, right? Because if A is a 90-degree angle, then it's a right triangle.
If A was a 90-degree angle, yeah, is it a
Well, yeah,
90-degree angle?
Hang on.
75.
What? Yeah, it's a 90 degrees.
Yeah,
Oh,
it's just
interesting.
90.
So the formula still works for a 90-degree angle too.
But if it was 90 angle, couldn't we just solve the other way?
If it was a 90 degree angle, it's
You use the formula based upon what you need and how what things are.
2.
Max, you doing okay?
Yeah.
What's going on?
4. No.
We're just
Got you. Okay,
nice
so
to
based
get-
upon which side you have, right? So it's the V formula because V is 2.72.
No. Hang on.
So I got 28.96. What did you get? Wait, what did you? I put it in one.
Check that before I hit enter.
2.72 squared, sine of 90, sine of 75 plus 2 things all. That's what I forgot. I forgot the 2 sign. I just did it sine on the bottom. Darn it, I don't want to do it all over again.
Sorry, it's called getting the correct answer. It's off this.
2.72.
Oh, yeah, probably that's the one.
Okay, now I got,
Mr. Hunter,
well, yeah, now I got a decimal. Did
Nine.
you get like 0.88?
What was it?
I got one issue at 93.
What did you do?
Yeah. You good there? You know how you
Beautiful
got
math is what I did.
90.
Hang on, let me just.
that? Okay, gotcha.
Oh.
Class, let's talk about something real quick here. See something happening, just to make sure. So this little 20 minutes and 40 minutes. It's kind of caught three people here real quick. If you guys convert this, Isabel, 1 second here. If you guys convert this into like what, 20 over 60, right? You get yourself a 14.33 repeating, right? If you start rounding off, then you're going to get yourself a little bit in trouble here because this is 75 plus, right? 40 over 60, right? And this becomes 75.666 repeating, right? So you don't want to do the repeating stuff as much as you just want to make sure that you're still adding things together as minutes and degrees. Okay, so yeah, so let's find the other angle together here. So if you're going to add B and C together, this will be 14 degrees, 20 minutes. This will be 75 degrees, 40 minutes. And you're going to add this up and then subtract it from 180. So when you add this up, 0, 0, that's going to be 60 minutes. That's going to be a 9 and an 8. And you know that 60 minutes is going to give you an extra degree here, right? So you got yourself an 89 degrees plus 1 extra degree to give us 90 degrees. And that's going to be,
Because they would have given you a sign of just under 90, which is not.
yeah, correct. So once you start rounding off, yeah, you're going to be off by 1.
I input,
Or you're not supposed to just do sign of.
I input 40 and 20 over 60 and it's 2/3 and 1/3.
Okay, yeah. And if your
Just
calculator does
that's-
calculator, yeah, if it's a fraction, it'll still work as a fraction. But once you start rounding, then you're in trouble.
Yeah, I usually, so what I've done, I haven't rounded until the very end.
Uh-huh.
That-
Yeah, that's fine. Uh-huh. Yeah. And if you just work it out just by the value itself. So this is just the addition of these guys, right? But then we subtract from 180 and obviously 90 from 180 is still going to be 90. So our triangle more looks like this right here, right? It's more like this. If we're going to draw it to scale ABC. C is 75 degrees, 40 minutes. B is 14 degrees, 20 minutes, and angle A is 90 degrees. That's okay. But according to formula, Abe was asking, can we use the regular geometry formula here?
Yeah.
Absolutely.
Have to do sign. Did you not have A, like length of
Okay, let's
A?
do it.
Or
You don't need, you
you
have,
need like
you just need
C.
base and height, right? You have the height, which is like.
You need base though, so you have to do,
Yes, you just do
Sine.
tangent.
yeah.
You just do tangent of 14, 20. or 14.
Okay, so you're still gonna, you have to use some trig functions,
Yeah, yeah.
right? Any which way. Okay. So this one, why is this better? It's just plug in and done, right? It's a formula
Yeah,
that we
but
could
I
do.
think
So
This one's quicker. You just do like the tangent.
And then you have to figure out what,
So I have B, right? Sine of, in this case, it'd be sine of A, which is sine of 90. Everybody good with sine there? And then sine of 75 plus 40 over 60. This would
You
be
can do
2
that as
times
75 plus 2/3, right?
2/3. Yeah, absolutely. And this one's going to be B, right? 14 degrees plus 20 over 60. So punch that in. What'd you guys get?
14.477.
So 14.5.
Round that.
You guys talk to me. Atali, Annette, did you guys get the same? Dylan, did you get the same? Okay.
No, but I don't do
So Abe got the same thing as you did, the 0.8 whatever, but he didn't have the right parentheses.
I use way too many. Put parentheses around these two. There's no.
Well, you can do
Oh,
parentheses around each
yeah,
term, but
no.
you need ones all the way around the
Yeah, I
top
got
fraction,
lots.
all the way around the bottom fraction.
it. Yeah.
So-
Yeah, that's what I do.
Yeah, I know.
We good now?
Yeah, because I forgot to put parentheses over the whole top, so it was just dividing sine of C by two
mhm.
sine of D. So
Yep, you need a big O parenthesis here, and then also because of that little two, you need a big O
I
parenthesis.
don't know, it's so much easier to write it out than doing it on the calculator. Like I always get lost in the calculator. for big ones.
Mhm.
But yours just looks easier, because the way it shows you everything. Like,
It's very easy.
Okay, I think we're all gonna get to Heron's formula. Why didn't I get to it last year? I don't know, but let's go for it here. So, Friday we'll actually do a little bit of reading on Hero, but this is what we got right there.
Teaching us more of this. This is confusing.
Let's do his accomplishments, guys. Here it is.
first vending machine, oh,
A coin for holy water.
I love it. Holy water. It's like O'Hare air from the Lord. Bottles of air. First syringe.
Okay, but in front back to
Wow.
the air, it's actually a really good idea in this day and age, because it's so
That's true.
like polluted.
If you could actually like sell pure air.
Well, not like just pure oxygen, but just like pure air.
Yeah.
Pure oxygen would kill you.
No, but if you just sold like pure air in bottles.
Uh-huh.
No, there's people who do that for like people who are switching altitudes often.
Oh,
Like,
that
yeah, it's just like if you're like in a high altitude, it's something around until we can use.
How interesting.
You just sell
I mean,
dehydrated
this
water.
week we do have bottle layers.
Yeah,
It's,
so-
oxygen.
It's like, it's not really like bottled air, it's like these like tanks.
So, you know, for
Yeah,
backpacking.
it's not like a
For
water bottle.
backpacking, all the food's dehydrated, so there's dehydrated water, you just add water, pure water. Pretty great. You sell that.
I'm pretty sure it's called water purifier.
That's funny.
That's just.
Okay. So he got his ideas from the Babylonian mathematicians, exactly the same thing as Archimedes. Archimedes is considered also one of the greatest mathematicians from the 250 BC era.
He had a lot of inventions.
Yeah, and he writes in his book, he just says, look, I just read a lot. And I read a whole bunch of like math textbooks from antiquity. That's what I did, and engineering textbooks. So it was kind of interesting to see. Okay, Hero's formula is huge. It takes a lot of time. So if you ever want to see it, you can go Khan Academy. He does it. How to derive it. It's just huge. In your book, it takes 2 pages.
Are we gonna divide
So we're not going to derive this one. We are going to use it
No,
though.
do tests.
So formula.
Please
Oh,
don't
I
make
didn't get the
our
formula.
students Do that for the test.
Do we need to know,
That, okay, that is in the.
do we need to know the formula? for
Oh,
the
it's
test?
the square root one.
Yes, and I'll give it to you guys. So let's go for it. Let's copy the formula.
That
All of the
formula.
formulas are in the formula.
Yeah. Uh-huh.
Yeah.
It would, well, no,
Okay,
this
or-
formula is.
Well, no, if
The
you
one
want,
before it is 2, but it's just the a squared one, so you just have to, but it's really easy to switch that into the b squared one.
Mhm.
So I think
That's
all
cool.
of them are.
Yeah, let's go for it. We have 6 minutes left, so let's put this together here. So Isabel, to answer your question, what is the semi-perimeter? Semi-perimeter of a triangle is, you add up all the sides, and what you do is you divide by 2.
And Mr. Ron, do you
Yeah.
have, just so we have time for my test questions?
Oh, yeah, oh, yeah, we should. That'd be easy enough here. So semi-perimeter is just half of the perimeter. Semicircle, half a circle, right? Semi-perimeter, half a perimeter. So if you guys want to write down the formula, you guys should. This one's going to be side, side, side. There it is. It's the side, side, side formula for area of a triangle here. So it's 1/2, and then you just add up A, B, C. And here the formula says this, you just take a square root of the S value, and then the S value is subtracted from each one of the individual pieces.
So it's S minus A, S minus B, S minus C square root.
Uh-huh.
Oh, it looks really complicated.
So what is that?
It's the semi-perimeter.
S is the semi-perimeter.
Oh, so you have to find.
How do you calculate it? You add up all the sides, divide by 2.
half the perimeter of the triangle, why would you even?
Wait, so you have to find a semi, because it's used in the formula to just find the area. So you have a formula to find. the
Why
half
don't you
perimeter.
just add A and B and C and thus get the perimeter?
Because you have to subtract it from the S value in the formula. Because the S value,
Oh,
so that S value is needed for this one.
So you're subtracting those values from half of the total.
The semi-perimeter is only useful for the area.
Yes, correct. So semi-perimeter of a circle of a square, triangle is only used in Heron's formula. I've never seen it used anywhere else. The reason for it is because the Greeks, when they thought of triangles, they thought of triangles being inside a circle. They thought like that's how they're thinking of triangles were. And so everything is a circle and connected to circles. So let's go for it, guys. 4 minutes. Find the area of this triangle. A is 23, B is 34, and C is 45. So let's go with S first. S is half of, and give me that value, please, when you have it here. So half of all the additions.
51, I think. Maybe 80, 90, 52. 52. Yeah.
Okay.
Or 102, so 51 is that.
51, okay. 51, anybody else with 51? 51, 51, 51? You do like a little
It's 51.
51, okay. Boom. So area of the triangle, according to Heron, is 51. 51 minus 23. 51 minus 34. So notice 51 is always going to be bigger than any one of those other ones, right?
Oh, yeah. Then we'll add up the back.
Mhm.
381.649.
And then if you want to, let's see, Isabel, did you subtract 51 minus 23, or did you just punch it in just like that?
I just punch it in like that.
Okay,
I guess if they were like whole numbers, if it was like 20, 30, and 40, then I just punch in 31, 21.
okay, if you could do it in your head sort of thing.
Yeah.
Gotcha. Okay, Isabel, what'd you get?
381.649.
81
There's a
point,
zero right now.
yeah,
That's
300
right.
I'm gonna go with 382, is that okay? Meters
Square.
squared.
Okay, that's actually not that bad.
This is so not that bad.
Yeah, we should always use this. We have to have side.
Uh-huh,
Oh, so now we have side, angle, side.
correct, yeah, so all the geometry formulas of angle, side, right, angle, side, angle, now we have it converted into that, which is kind of cool.